Greetings, junior scientists, citizens of the great big weird wild and wonderful world in which we live. As always, I'm your humble science communicator, the Great Orbax, coming to you from the Department of Physics at the University of Guelph. I'd like to welcome you to our May 2024 Stargazing Guide. Well, April was pretty exciting, wasn't it? The total solar eclipse had everyone talking about space and the stars. But just because it's over doesn't mean that we've lost our excitement for what lies beyond the edge of our skies. By the end of May, our sunset will be as late as 8:55 p.m. and our sunrise will be as early as 5:43 a.m. Now that means we'll only have 9 hours a night for stargazing, but those hours will get warmer and less cloudy as the month goes on. This month, we check in on a couple of smaller constellations, cross our fingers for the next meteor shower, and we take a little time to learn about a phenomenon called the Aurora Borealis. All this and more, if we just take some time to look up. Our constellations this month are small, but mighty. Coma Berenices, or Berenice's hair, was named for Queen Berenice II of Egypt, who sacrificed her long hair for the gods. Now, Coma Berenices is small, with only 3 main stars. Canis Venatici is Latin for hunting dog, and this hunting dog belongs to a much bigger constellation, Bootes the herdsman. Canis Venatici is also small, with 2 main stars. Now, while both these constellations are small, luckily for us they appear beside one of the most recognizable asterisms in the night sky, the handle of the Big Dipper. They also appear just above one of the brightest stars in our sky in May, Arcturus. Look for them nestled together right in that patch of our eastern sky. A chunk of hair and an angry dog. Planet spotting this month is going to be difficult. Seeing Venus is unlikely. Mars will gain some visibility as it rises higher and higher above the horizon as the month goes on. And our gas giants are just too close to the sun to see that well, with Jupiter in solar conjunction on May 18th. Your best bet for planet spotting is May 9th, when Mercury will be in its greatest eastern elongation. It'll appear low in the east just before sunrise. The full moon this month is May 23rd. It was referred to as the corn planting moon or the flower moon by many European cultures. The Mi'kmaq moon for May is Skolchewie Goose, the frog croaking moon, named for the sound that frogs make when they croak. Skolch! The Ojibwe of the Great Lakes called the May full moon Zagabaga Gizis, or the budding moon or leafing out moon, as Mother Earth's healing medicines can once again be found. Throughout May, you should be able to see meteors emanating from the constellation Aquarius, notably from one of its brightest stars, Eta Aquarii. Eta Aquarii's meteor shower occurs when Earth passes through the remnants of Halley's Comet, particles of space dust that separated from the comet hundreds of years ago. At the peak of this meteor shower, you may be able to see upwards of 60 meteors per hour in South America, and here in North America, we should be able to spot up to 30 meteors per hour. Fortunately for us, the peak of the Eta Aquarii's meteor shower occurs on the night of May 6th into the morning of May 7th, coinciding with the new moon. It should be so dark that these meteors light up our night sky. Good luck, junior scientists! Alright, well, our sun is a constantly exploding nuclear reactor. When these explosions occur, not only is energy in the form of light sent our way, but so are charged particles. The charged particles that get ejected from the sun's corona, electrons, protons, alpha particles, are known as a solar wind. These travel through space and are redirected by the Earth's magnetic field, deposited at the magnetic north and south poles. Now, when particles interact with the gas in our atmosphere, they exchange energy, and that exchange can take place in the form of photons, or light. Blue and pink light correspond to nitrogen at different levels in our atmosphere, while red light comes from high altitude oxygen. But low level oxygen yields a characteristic green light that we often associate with this phenomenon. These are the auroras. Aurora australis in the south and Aurora borealis here in the north where we are. Observing this dazzling display is a bucket list for many Canadians, and the closer you live to the Arctic, the better your chances are of seeing them. Now, about every 11 years, the sun's magnetic poles flip. This is known as the solar cycle, and that cycle directly affects the activity that's taking place in the sun. Right now, we're approaching a solar maximum, meaning that in the next few years, we may see more and further reaching auroras than we've seen in a very long time. Geomagnetic storms will also affect aurora placement. I mean, just last year, we spotted the aurora borealis in the Waterloo region. If you want to check on your odds of spotting the aurora borealis, or you just want to learn more about it, check out the Space Weather Prediction Center of America's National Oceanic and Atmospheric Administration here. Oh, one last thing. Auroras aren't just limited to Earth. Any planet with an atmosphere and magnetic field is also likely to have auroras, like this one seen on Jupiter. The vastness of space can sometimes be difficult to understand, but I like to think that when we look out there, when we take the time to observe the cosmos and its resounding beauty, that we all feel just a little more connected as we spiral around on this little blue ball that we call home. I wish you clear skies, my friends, so that you can take some time to look up. See you next month, junior scientists, and don't forget to have a Science-tastic day. Special thanks to Royal City Science's own planetary geochemist, Dr. Glynis Perrett, for her help preparing our stargazing guide. And the Royal Astronomical Society of Canada,